Hey guys, hope you're well. So this lesson is going to be about displacement time graphs. So let's begin. So here we have a person that is going for a walk. They start at their house. Okay, so that means the starting position is their house. So let's just write that over there. And then I'm also going to show you on a little number line like this that I showed you in one of our previous lessons when we first started looking at displacement. And so this would be the zero position, would be their house. Okay, now it says that assume right is positive. Okay, so yeah, don't worry about that on the number line, but over here, that's very important. So let's see how this all works now. So for the first part, they go from their house and they go up to 4 meters. Okay, now they said that right is positive. So we know that we are going to be over there. So that's where the person is relative to their house at this point. Okay, now think about this carefully. For this next part, which I'm just going to go from here to here, you can see that, because some learners get very confused with this. So if we go here, this part is now you back at the house. Can you see this zero line is the house? Let's rather highlight that. That is the house. So what that person has just done there for that red part is they've actually turned around and they've gone back to their house, okay? But then they keep walking, but now it's going into the negative values. So now we're going into the negative values, and we're going all the way to -4. So they keep walking, up to there. So this is where the person is now. They are 4 meters to the left of their house. So they walked this way, then they turned around, and they walked past their house again, and then they walk to the other side, okay? Now, if you look at this part over here, they're not moving at all. Why do I say that? Because if you look, the distance from their house, the -4, it stays -4. Can you see that? So for that part over there, they are not moving, so they're staying exactly over there. Now we're going to go on to some questions on this graph. And that's how this lesson's going to go. We're going to look at graphs like this, and then we're going to answer questions about the graph. Then we're going to do a question like this, and then we're going to answer questions about the graph. And then we're going to do this, answer questions about the graph. You get the idea. Okay, so we've just done this graph. Now we're going to answer some questions about it. So the first question says, what is the total distance walked by this person? Well, we've looked at these before. So we know that we've walked 4 meters over here. So that's 4 meters. And then we walked a total of 8 meters over here because we went all the way from 4 to -4. So that's 8 meters. So it was 4 meters plus 8 meters, and that'll be a total of 12 meters. The next question says, what is the average speed for the full 15 seconds? Now, in previous lessons, we've learned that speed is equal to distance over time. And we've just seen that the total distance is 12 meters, and the total time on our graph is 15 seconds. And if you had to calculate that, you would end up with 0.8. And the units for speed will be meters per second. This question says, describe the location of the person at 10 seconds. So at 10 seconds, that's when the person, you remember how we drew this? That's when the person finished this part over here. Okay? So the person is currently over here at 10 seconds. So what we'll say is that they are 4 meters to the left of their house. Because we said right is positive, so left is negative. So we will say that the person is 4 meters to, or let's just say 4 meters left, like that. Okay, that's when they say location, it's another word for displacement. This next one says describe the location at 15 seconds. Well, what we saw was that between here and here, in that part there, they did not move. So at 15 seconds, they're still going to be 4 meters to the left of their starting position. Question E, what is the person doing between 10 and 15 seconds? They are not, they are not moving. And then F, Determine the velocity between 5 and 10 seconds. That's a good question. I'll show you why. So we know that velocity, we've learned this before, it's equal to the change in the displacement over the change in time. So it's the final displacement minus the initial displacement over the final time minus the initial time. But they're only asking between 5 and 10 seconds. So they're only talking about that part over there. Now, when we drew this thing over here, that was from here all the way up to there. That was that part over there, right? And you might need to just pause and make sure you agree with me on that, okay? Don't just keep going. Make sure you agree and you say, oh yes, I do remember we said that. So what we can now do is we can look at the velocity as the final displacement. Now, what is the final displacement? Well, that was, your final is this part over here, and your initial was this part over here. Some of you are like, yeah, but Kevin, wasn't this the initial? Wasn't that the start? Yes, but we're only talking between 5 and 10 seconds. So that becomes your starting position and your ending position. Okay, so the displacement at the final point is -4. So you say -4 minus your displacement at the starting position is +4, right? Okay, so we put a +4 over there. And then the time is going to be not 15 seconds. You're going to say your final time minus your initial time. And this would eventually give us, at the top, it'll give you -8. And at the bottom, you would end up with 5. And so this is going to give us -1.6. Now, remember, they said assuming that right is positive, but we just got a negative answer. So we'll say, therefore, the velocity is going to be 1.6 meters per second. And then we're going to say left. Because if right is positive, then left is negative. And we did get a negative answer. And so there would be our answer over there. Now with this one, I can see on the displacement, we're going up to 60. So I just want you to pretend that this is actually 10, 20, 30, 40, 50, 60, -10, -20, -30, -40, -50, -60. So it says, I start riding my bicycle from my house. Okay, so the starting position is going to be the house, which is that line over there. So that would be the house, and I'm going to write it over here as well, and then we're starting over here. Your teacher's not going to show you this part, but I'm just showing it to you because I think it helps you to understand what's happening. Okay, so that's house. So let's see what happens here. So we're first going to analyze this graph, and then we'll go do some questions on that graph. So for the first part, you can see, and it says that assuming that east is positive. Okay, so we can see here that this person starts off and gets to 60 meters. Okay, so they start at their house and they go east is positive, so they go 60 meters over there. So that's the first part. So that would be that part there, that part there. Then for this next part over here, they stay 60 meters. That means they're not moving because they're not moving any further away from the house. It stays at 60. So we're just going to stay there for the 60 meter part. Then for this part here, can you see that we are coming back towards the house? Because this is the house, remember? And you can see that, yeah, at this point here, the displacement is 0. So that means we're not away from the house. We're at the house. So what that would look like is on our graph, we came all the way back to the house. So that's where we are there. Then for this part, can you see that the displacement is now becoming negative? All that means is we're going in the opposite direction of what we chose as positive. So now we're going to start going towards the west side. Okay, so for that part, we go all the way to 40, but it's 40 on the west side. So we're going to go up to there. Okay, and then over here, we're going back to the house again. So what that means is we're actually turning around. We're turning around and we're going back to the house. And so there we are. We end the journey back at the house. You might need to take 20 minutes if you want to really sit and understand this. It's very important that you do understand this. So here are the questions that we're going to do. So it says, what is the total distance traveled? Okay, well, that's easy. We've done that in previous lessons. So we know that this first red part was 60 meters. That was this part over here. That was 60 meters. So we can say, okay, like for question A, we can just say 60 plus. Then for this green part, there's no distance over there. We did not move over there. Then for this purple part, we went back to the house. That was another 60 meters. That was this part over here. So that's 60 meters. And then this blue part over here, we traveled 40 meters. And then this yellow part, we traveled back 40 meters again. And so 60 plus 60, 120 plus 80 is 200 meters. That is how far this person traveled. 200 meters. Next question. What is the average speed for the full 55 seconds? Okay, so speed, we know speed is equal to the distance over time. So we've just calculated the distance in question A. So we've got speed is equal to 200 divided by the time, which is 55. You see, each of these blocks is 5 seconds. So if this is 50, then this is 55. So 55 seconds, if we calculate this to 2 decimal places, 3.64 meters per second. So 3.64 meters per second. Question C, describe my location. When they say describe my location, they're just saying your displacement at 30 seconds. So at 30 seconds, we're over there. We can see we are all the way back at the house. If I show you on this part, the 30-second mark was, so this first red one was the first 10 seconds. Then we waited over here for 5 seconds. And then this purple part is when we came back to the house. You see, this is when we came back to the house. So the location is going to be 0 meters. You could even say we're back at starting position. Describe my location at 35 seconds. So 35 seconds, here's 35 seconds. Okay, so that's over here. And so if you look on this graph, if you read it off, it's negative 20. Negative 20. That means we are 20 meters, so 20 meters west of the house. Because they said that east is positive, so all of these are east. Okay, and then all of these will be west. So we are 20 meters to the west of the house. It's going to be over here. And then this question, determine my velocity between 15 and 40 seconds. Okay, so we know that velocity is equal to change in displacement over change in time, which is the final displacement minus the initial displacement over the final time minus the initial time. Now, we obviously know that east is positive. Okay, so it says between 15 and 40 seconds. So 15 and 40. So 15 seconds, we are over there. And then, so that's going to be our initial displacement and our initial time. And then at 40 seconds, we're here. So that's going to be our final displacement and final time. So now we just go fill into the formula. So that's going to be negative 40. See, it's a negative 40 minus our initial displacement is 60 over our final time, which is 40 seconds, minus our initial time, which is 15 seconds. And if we had to go calculate all of that, we end up with negative 4. Okay, now if you end up with negative 4, then you need to change your answer to 4 meters per second. But now east is positive. So then, because we got a negative answer, we're going to say west, like that. Here's our next example. Sarah goes for a walk. North is positive. Okay, so that means that all of this is north, and then all of this below is south, and the starting position would be here. So this is start. Okay, so it says that Sarah goes for a walk. Okay, so for the first part, can you see that Sarah goes up to 2 meters? Okay, so Sarah starts over here at the starting position and goes 2 meters to the north, well, now we said north is positive, and that's why I'm going in that direction over there. If she started walking that way, then I would have gone that way over there. So 2 meters to the north, so we're going to go like that. So that part could be there. Then you see for this part here, Sarah isn't moving at all, because have a look here. The distance or the displacement is staying at 2 meters. So that's just going to stay over there. Then for this part up to, I don't know, like 5.5 seconds or whatever, she comes back to the starting position. Let's do that in a different color. For this part here, you can see the displacement is becoming less. Here it's 2, here it's 1. So she's coming back. So what that looks like is that. Okay. Then for this part, she is now going in a south direction. She's now going to the south of the starting position. So she's going 1 meter to the south. So there. Okay. And then over here, there's no movement at all. So there's no movement over there. We can see that the displacement is staying the same. So that just stays over there. And then this part here, you can see she's going back to the starting position, back towards the starting position. And so that would go like that, back to the start. Right, so here's the question. So the first one says, how far does Sarah walk in total? Well, that's just adding up all these little distances. So that would be, for this first red part, that was 2 meters. So we say 2 meters plus. Then over here, she did not move. Then over here, that was 2 meters again. You know, that's where she came back over here. So that's going to be 2 meters. And then for this purple part over here, that was 1 meter. You don't look at the direction or the plus and the negatives when you're looking at distance, because distance is a scalar. And remember, when they say how far does someone walk, that's just distance. That's not just displacement. And then this distance over here was 1 meter. And so 2 plus 2 plus 1 plus 1 is 6 meters. This next one says, describe Sarah's position at 7 seconds. So 7 seconds is over here. So you would read it off here. So if you had to look on the displacement, it's -1. So that means that she is, let's say here, 1 meter south. Because north is positive, so then south is negative. And we also said that when we drew this graph over here, this black line over here was where she was not moving, and it was this dot. And if we read it off there, we can also see it's -1. This one says, calculate her velocity over the first 2 seconds. Okay, so the first 2 seconds is this part over here. So we know that velocity is change in the displacement over change in time, which is the final displacement minus the initial displacement over final time minus initial time. So this part here would be the final displacement as well as final time, and then this part here would be initial time and initial displacement. And so that's going to be 2 take away 0 over 2 take away 0 again, and that's going to give us 1. Now that must be in meters per second, and then we will also say north, because north is positive, and we just got a positive answer. Question D says, calculate her velocity between 4 and 6 seconds. So that's from here to, okay, let's just get rid of all of that, up to here. So this will be the final displacement, final time. This will be the initial displacement and initial time. So we'll go do that calculation now. And so with our calculation, we're going to say V is equal to the change in displacement over the change in time. And so that's going to be final displacement minus initial displacement over final time minus initial time. And so that's going to be -1, because that's your final displacement, minus 2 over 6, because that's your time, minus 4, because that's your initial time. And that's going to give us -3 at the top and 2 at the bottom. And so that's going to be -1.5, which is then 1.5 meters per second south. South because north is positive. So if you're getting a negative answer, then that means south. And then this last one, calculate her velocity between 6 and 8 seconds. Okay, so between 6 and 8 seconds, we did say that she's not moving, so her velocity should be 0, but let's go calculate it. So at 6 seconds. Oh, that line's actually a little bit weird. Okay, but we'll just assume that it's there. So that there is going to be your, or let's first start at the 8 seconds. That's going to be your final. That will be your initial. That'll be your final time and your initial time. So if we had to go do a calculation, not with that, sorry, with velocity, we know that that's change in x over change in time. And so that's going to be your final displacement minus your initial displacement over your final time minus your initial time. And so that's going to be -1, because that's this part. Then there's a minus. And then your initial is also going to be -1. So you're going to put a -1 like that. And then your time is going to be 8 minus 6. And so the top part here is going to end up becoming 0. So we're going to get 0 over 2, which is 0 meters per second. And so Sarah is not moving, and that's why her velocity is 0 meters per second. Okay, let me just put that properly. M dot S -1. We've got 2 more examples. Well done for making it thus far, guys. So here we have a question that says, Greg is sprinting. Assume west is positive. So that means that west is positive. So we know that this line over here is always the starting position. And so if west is positive, then that would be this part here. That's west. That's positive. And then east is negative. And so for that yellow line, I'm also just going to fill in that that is the start. So let's see what happens. So Greg is sprinting, west is positive. Okay, so Greg in the first part goes up to 8 meters. So that's up to there. So that's going to be 8 meters like that. Then for this part over here, Greg is not actually going to be moving, because you can see that the displacement from his starting position is staying at 8 meters. So that's just going to be like that over there. Then for this part from C to D, Greg is turning around and going back to the starting position. Okay, so that would look like this. Turning around, going back to the starting position. That's at point D. You can actually put the letters D, C, and then A would be at the starting position. So A, and then this was also B. Right, so then what happens is that we then start going in an easterly direction to point E, which is 8 meters. So that would be, let me just get a different color. So that would go to there. So that would be point E. And then, okay, well, I've got to show the color as well. So that's from there. And then from E to F, you can see we're not going to be moving at all because the displacement remains at -8. So that would just stay like that. So that would also be letter F. And then this person, Greg, then turns around. It's quite a funny story. Greg sprinting. So Greg sprints one way, quickly turns around, sprints the other way. Pretty random. And then let's do this one in yellow. So then Greg goes back towards the starting line. So what that would look like is it would go from here then to the start again. So this would be letter G. And there we have it. And so now we're going to do some questions on that. So it says, number 1, determine the velocity from 0 to 2. So we know that velocity is change in displacement over change in time. So that's going to be final displacement minus initial displacement, final time minus initial time. So it's between 0 and 2 seconds. So it's this area here. So B will be where we get your final displacement and final time, and then initial displacement and also initial time. And so that's going to be 8 take away 0 over 2 take away 0. And so that's going to end up being 4 meters per second. And then because it's positive and west is positive, we should say west. Okay, so that's for, so let's just say here 4 meters per second, and that is west. Okay, number 2 says determine the velocity from 4 to 8. So that's going to be from here all the way to here. Okay, so then in that scenario, this part here will be your final displacement and your final time, and then this part here will be your initial displacement and your initial time. And so if we had to go then use our formula, which is change in displacement over change in time, which is final minus initial over final minus initial. So that's going to end up being minus 8, because that's this value over here. Take away 8 divided by time, which is 8. Take away 4, and that's going to be negative 16 over 4, which is negative 4. So when you get a negative answer, all that you then do is you go to the next line and you say 4 meters per second. Now, because you're getting a negative answer and west is positive, then that would mean east. So 4 meters per second east. So we can say 4 meters per second east. And the last question for this one, and then we've got one more example after this one. Okay, so determine the velocity from 8 to 10. So from 8 to 10. Okay, so from 8 to 10 is going to be this part over here. So this is where Greg wasn't moving. So we should find that the velocity will be 0. But let's just see how the calculation works. Okay, so if we just go to use our calculation, you would see that this displacement is negative 8. So negative 8 minus, and then this displacement is also negative 8. And then the time is going to be 10, take away 8. And if you had to go calculate this, you would end up with 0 meters per second. And so that is why we say in this area and in this area, Greg actually wasn't moving. So here's our last example for this lesson. So here we're going up to 40 and down to negative 40. So what I'm going to do is I'm just going to put make this 10, 20, 30, 40, 50, 60, and then negative 20, negative 30, negative 40, negative 50, negative 60. Okay, east is positive, so everything above is going to be east, everything below is going to be west, and then this would be the starting position. So we can just say here that that's the start. Okay, so the first thing that this person does is they go 40 east. So let's do that in red. They go 40 east, so that's going to be up to there. Then from B to C, they are not moving because the displacement remains at 40. So they're just staying 40 the whole time. So it just stays there. And then from what I'm going to do now, instead of going from C to D and then to E, I'm just going to go straight from C to E because it's one movement. You see the line just stays the same. Okay. You can go from C to D and then D to E. It's the same thing. But all that happens is we go from 40 to minus 40. So it's just going to go all the way from here all the way to there. But if you wanted to stop at point D, then you would have stopped over there. Okay, but I just want to save a bit of time because we've done this a few times now. So we're just going to go to there. And then from E, you could go to F, but because it's one continuous line, we can just go straight to G as well. So all that it does is it just goes from negative 40 to 20. Okay, so from negative 40 to 20, positive 20, so it just goes like that. And then from 80 to 90, so at that point, or from 80 to 90, we're just staying at the 20 mark, so that means we won't move over there. And then from H to I, that means we're just going back to the start position. So I'll just do that in yellow. So from H to I, we're just going back to the starting position like there. Okay, so with this first question now, it says determine the average velocity between 30 and 50 seconds. So that's between here and here. So we use our velocity equation, which is change in x over change in time, which is final minus initial over final minus initial. And so it'll be negative 40 because that's at point E, that's your final position and your final time, and then your initial and your initial time. And so it's going to be negative 40 minus 40 over the time, which is going to be 50 take away 30. And so if we calculate that, you're going to end up with negative 80 at the top and 20 at the bottom, and that's going to give us negative 4. So because it's negative 4, then your answer will be positive 4 meters per second. And then if east is positive, then west is negative. And we got a negative answer, so we're going to say west. Okay, this next question says, determine the velocity for the first 30 seconds. Okay, so it's the velocity for the first 30 seconds. Okay, so if it's the first 30 seconds, then this would be your final position, your final time, and then this would be initial and initial. So if we then go use the formula, V is equal to delta x over delta t, it's going to be 40, because that's this displacement, minus the initial displacement, which would be 0, over this time, which would be 30. See how it's 30 over there? Take away 0. And that's going to give us 1,33 meters per second. So because we're getting a positive answer, we could say east. So 1.33 meters per second east. Okay, this question says, what is the boat doing from G to H? So what we said from G to H was that the boat is not moving. So not moving. And then this one says, determine the total distance traveled. So the total distance traveled will just be all of these added together. So the first part was a 40 meter. Then this part here we could say was 40 meters. Or you could just say that this whole part is 80 meters. You know, from here all the way to here is going to be 80 meters. Plus this part is going to be from negative 40 up to positive 20. That's 60 meters. So that's 60 meters. From negative 40 up to 20, 60 meters. And then from 20 to 0, that's just going to be 20 meters again. So 20 meters. And so if we're to add this all together, that will give us 200 meters.